All right, welcome back. In today's explainer, we are going to tame one of the most common, and let's be honest, often messiest, forms of data out there, text. We're going to dive deep into Python's powerful toolkit for string manipulation, and by the end of this, you'll be a total text wrangling pro. So before we even write a single line of code, let's just stop and think about why this matters so much. The simple truth is, our entire digital world practically runs on text. Strings aren't just some data type you learn about. They are the fundamental language of how we all interact online. Which leads to this big question, right? Why is text the most common data type we deal with? Well, it's because it's human data. It's how we talk, how we share ideas, how we record pretty much everything. And our job as developers and data people is to wade into this giant, unstructured ocean of text and actually make sense of it. And look, this isn't just some abstract idea. It is happening literally all around us. Think about it. When Netflix figures out what you want to watch next, it's crunching through text data. When Amazon manages its mind-boggling inventory, it's processing text from millions of orders. Your social media feed, customer reviews, even critical financial reports, it's all just raw, unstructured text that powers the whole machine. Okay, so if text is this massive ocean of data, then strings are the water molecules. They are the absolute fundamental building block for handling any kind of text in Python. So let's get to know them a little better. So what exactly is a string? Well, on the surface, it's simple, just a sequence of characters wrapped up in some quotes. But here's the secret sauce. Python sees a string as two things at once. It's a single object, but it's also a collection of individual characters. And that duality, that's what gives us all the power to manipulate it. And this is where it starts to get really cool. Every single character in a string has its own address, what we call an index. Now, you gotta remember, Python starts counting from 0, so the very first character is always at index 0. But, and this is a great trick, you can also count from the end. Using a negative index, -1 will always get you the last character, -2 the second to last, and so on. This is incredibly handy when you don't know how long a string is, but you need to grab something from the end. Okay, so what if you need more than one character? What if you need a whole chunk of a string? That's where slicing comes in. You just give it a start and a stop index. The key thing to burn into your memory here is that the slice grabs the character at the start, but stops just before the character at the stop index. You can also leave the start or end blank to go all the way from the beginning or to the very end. And that last one you see, //1, that's a classic Python one-liner for completely reversing a string. So simple, but so powerful. All right, so now we know how to access any part of a string we want. The next logical step is to start changing it. So let's open up Python's built-in string toolkit. These methods are the bread and butter, the things you'll be using every single day to clean, transform, and reshape your text. First up, let's deal with a super common headache, messy whitespace. You see this all the time, especially with data that comes from user input. The .strip methods are your precision tools here. You can use .lstrip to clean just the left side, .rstrip for the right, and the planl.strip to take care of both at once. It's almost always the first thing you should do when you're cleaning up data. Now, these two methods are really two sides of the same coin. Let's say you've got a string, like a sentence, and you want to break it down into individual words. .split is your tool. Bam! It turns one string into a list of smaller strings. Now, what if you have the opposite problem? You've got a list of words, and you want to build it back into a single sentence. Well, .join method does the exact reverse. It's a fantastic way to deconstruct your data and then build it back up exactly how you want it. You know, to a computer, Python with a capital P, Python all lowercase, and Python in all caps are three completely different, unrelated things. This can cause huge problems when you're trying to search or count things in your data. So standardizing the case is the solution. By forcing everything to be, say, all lowercase with .lower, you make sure that you're always comparing apples to apples. It's a simple step that makes your analysis way more accurate. Sometimes all you need to know is, hey, does this word exist in my text? And if it does, where does it start? That's exactly what the .find method does. It scans the string and gives you back the starting index of the word you're looking for. Now here's the most important part. What happens when it doesn't find it? It doesn't crash, it doesn't throw an error, it just calmly returns -1. And that's a clear, predictable signal you can use in your code to handle cases where the text you're looking for just isn't there. Okay, so we've cleaned our strings, we've dissected them. Now let's talk about building new strings and doing more intelligent kinds of modifications. This is where things start to get really dynamic and powerful. This slide really shows you the evolution of building strings in Python. On the left, you've got the old way, concatenation, just sticking things together with plus signs. I mean, it works, but you can see how quickly it gets messy and hard to read. But on the right, you have the modern, and frankly, way better method, f-strings. By just putting an f at the beginning of your string, you can drop variables right inside curly braces. It's not just cleaner, it's a complete game changer for writing readable code. And this is why f-strings are the absolute gold standard now. You're not just plugging in a variable's value, you can actually run real Python code inside those curly braces. Look at this example. We're calling the .upper method on the name variable right as it's being put into the string. This lets you format and change your data on the fly, which keeps your code incredibly short and to the point. Now, when it comes to replacing text, you've got two main tools in your belt. For a simple, straightforward swap, like changing every cat to dog, the built-in .replace method is perfect. It's fast, it's easy. But what if you need to replace something more complex? Like, say, every single email address in a document. For that, you need to match a pattern. And that's when you bring out the big gun, .reg.sub from the regular expression module. Think of it like a scalpel versus a Swiss Army knife. You just have to pick the right tool for the job. Okay, this is one of the most important rules you need to understand about Python strings. They are what we call immutable. That's a fancy word that just means they can never be changed. When you call a method like .replace or .strip, you are not editing the original string. What's actually happening is Python is creating a brand new string in memory with your changes applied. So if you want to keep those changes, you have to remember to save that new string to a variable. Woo! We've covered a lot of ground here, right? We've gone from accessing a single character all the way to formatting complex sentences. So let's just take a quick second to recap the essential tools that we've just added to our Python toolkit. Let's just boil this all down into a simple mental checklist. When you need to read from a string, you're going to reach for indexing and slicing. When you get some messy, inconsistent data, your first step is to clean it with .strip and .lower. When you need to break down or build up your text, you'll transform it with .split and .join. And finally, when you're creating new dynamic text from variables, f-strings should be your go-to tool to format it. So we've gone through the tools, we've seen the examples, we've recapped the basics. But look, the real power here doesn't come from just knowing these methods exist. It comes from actually applying them to solve real problems. So I'll leave you with this final thought. Look around at the text data in your own life, your own projects. What messy reports or log files or user comments can you now take on and make sense of with these amazing tools?